This is Mrs. Cucci's College Now Pre-Calculus class. The topic we are focusing on is partial fractions. So our objective today is to be able to decompose rational expressions into partial fractions. So all that means is we will take a fraction that looks something like this. And we would separate that into a sum of two or more simpler rational expressions. So in this case, this is what it would look like, and this lesson is going to show us the steps in order to get from the left side to the right side of this equation. So for the terms that we need to know, in the equation, each fraction on the right side is called a partial fraction. And the expression on the right side is the partial fraction decomposition of the rational expression on the left side. So again, all that is separating your original fraction into these two partial fractions. So moving on, these are the listed procedures for decomposing a rational expression into partial fractions. You may want to copy these down. We're not going to go through them because the examples will be a little bit more helpful than going through these official directions, procedures. But I am going to write in here for number 3, what this means is this. So you can copy this down into your notes. And once we go through some examples, you can refer back to the procedures. Right, so again, these are the procedures that we're going to go through, but the examples will be much more helpful. So write this down, and we'll move on. So example 1. We are going to take this fraction and decompose it. First thing we want to look at is the degree of the numerator and the degree of the denominator. Again, the degree of an expression is the greatest exponent. So the numerator has a degree of 1 and the denominator has a degree of 2. Because the degree of the numerator is less than the degree of the denominator, we are going to begin by factoring the denominator. So I'm going to do that to the side up here. We know that 2x squared plus x minus 6 factors into x plus 2, 2x minus 3. All right, going back to our expression, what we need to do is to separate those factors such that we have a, which is some constant that we're going to find, over x plus 2, plus b, which is another constant that we're going to find, over 2x minus 3. The next step is to combine the two fractions on the right. So let's write this over, 4x minus 13 over 2x squared plus x minus 6 equals, we know that to combine two fractions, they need to have the same denominator, so we would go ahead and multiply this denominator by 2x minus 3. If we change something if we multiply the denominator by something, we also have to multiply the numerator. And we're going to multiply b by x plus 2, and the denominator there by x plus 2 as well. This leaves us with a times 2x minus 3 plus b times x plus 2 all over x plus 2, 2x minus 3. Now we know that the denominator on the left side is equal to that denominator on the right side because we factored it up there to the right. So what that also means is that the numerator, 4x minus 13, equals the numerator on the right side. So we're going to set those equal to each other. So I'm going to erase what we have and set those equal to each other. Okay? And I'm going to note on the side, because we're going to come back to this with every example, that this equation is true for all of x, all x values. So what that means is that we can substitute any value of x and still have a true equation. So I am going to choose, and you'll see why I'm choosing it in a second, x equals 3/2. So we'll substitute 3/2 in for x. All right, and we will continue to simplify. Six minus 13 on the left. Sorry about that. We had a little problem, so we're starting here. So all we've done so far is we substituted in 2/3 for x, and we're simplifying. So that leaves us with, oops, this was a 13, -7 on the right, (7b over 2 on the left. We eliminated our a. So that's how we want to choose our x's. So our original equation up here, we could tell that we could eliminate the a in order to solve for b if what was in the parentheses equals 0. So substituting in 3/2 for x makes what is in parentheses? 0. And we are left with b equals -2. Now, let's take our I'll put b equals -2 up here. Now we want to find our value for a. So I'm going to erase this. And in order to find a, we need to make that the left side of the equation, that b equal to 0. So in order for b equal to 0, it needs to be multiplied by 0, or in order to eliminate the b. So we're going to use x equals -2. So we will let x equal -2. And solve. It will eliminate the b. And that will leave us on the right with -7a. Solve for a. That's an equals. We have a equal to 3. So now that we have our a and b, I'm going to erase. We can go back to the original equations and substitute in for a and b. So we had a over x plus 2. This should be at the top of your sheets. Substitute in. And we have the decomposition of that original fraction. So that's all it was. Again, it's a number of steps, but nothing that's too difficult. Now to check ourselves, what you want to do is enter it into your calculator. So you would enter exactly what is on the left side here into your calculator. As your first, so your, I think in your calculator it says f of x1 or y1. You would enter the whole right side of this equation into your calculator as f of x2 or y equals 2, depending on which calculator you're using. And then you would go to your table and you would compare to make sure that both columns were exactly equal. Okay, so we're going to move on to one more example. So again, to check, use the table feature on your calculators to make sure those values are exactly the same. Okay, so example 2. 7x squared minus 29x plus 24 all over 2x minus 1 x minus 2 squared. So first we want to think about the degree. And again, the degree of the numerator is smaller than that of the denominator. So we're going to go ahead with the steps that we were using before. And so the degree of the numerator here is 2. And we know if we multiply this the denominator out, the highest degree would be x cubed. So let's go ahead and set this equal. This will be your left side. We do have a third term here we will have to find. Okay, and then we want to combine what's on the right side. So in order to do that, we multiply the numerator and the denominator by a constant and then combine them. So I'm just going to switch to combining them here. So I'm going to erase this. And we get one. You will probably, once you're doing these yourself, you'll have an extra step in between to make sure we're combining accurately. I skipped that simple algebra. Okay. So now we can set the numerators equal to each other. So let's go ahead and do that. And again, this equation, just like before, is true for all of x. So we can substitute any value of x and still have a true equation. So let's first, so in order to have this 2x minus 1 equals 0, we can let x equal 1/2. So let's substitute in 1/2. Okay, so see what I did there? I substituted 1/2 in for x. I don't even have to write what's multiplied by b and what's multiplied by c because it's being eliminated, because 2x minus 1, if you substitute in 1/2, is 0. So this is all we're left with. Okay, and then go ahead and solve for a. Once you combine everything, you'll have 45 over 4 equals 9. Fourths a equals 5. So pause this. You might have a couple steps in between. And okay, we are almost done. So the second step is, in order to have x minus 2 equals 0, we want to let x equal 2. So now we're going to let x equal 2. Okay, so go back. Again, apologies if we go slightly over 20 minutes, but we are almost done. And we get c equals -2. Now to find b, we want to choose any value for x except 1/2 or 2. And then we can replace a with 5 and c with -2. So let's just go ahead and let x equal 1. We'll substitute it in. I'm using my 5 for a. And we get 2 equals 5 minus b minus 2, and then b equals 1. So you go ahead and put, so we have a equals 5, c equals -2, and b equals 1. So you go ahead and substitute those back in to your original equation, and you have your answer for partially decomposing 7x squared minus 29x plus 24 all over 2x minus 1, x minus 2 squared. And again, to double check yourselves, go ahead and put each value into your calculator and go to the table and make sure they are exactly the same. Come to class with questions.